All right, this is Organic Chemistry Laboratory Chem 2125, and in this lab lecture we'll be looking at purification of benzaldehyde. More information on this lab lecture you can refer to your textbook section 6.4b from page 75 to 76. So benzaldehyde is an organic compound that belongs to a class of compounds which contain the carbonyl carbon. And in a more IUPAC nomenclature system, this compound can also be called benzene carboxyaldehyde. It has a molecular formula written as C7H6O and molecular weight 106.12 gram per mole. At nearly room temperature, it exists as a colorless liquid, and because of its almond-like odor, you will find mostly applied in pharmaceutical industries. This liquid has a density of 1.044 gram per ml, and it boils at 178 degrees Celsius. The compound is nonpolar and it is immiscible in water. So the problem with impurity in benzaldehyde is that in a benzaldehyde container it is usual to find carboxylic acid as a contaminant, and the reason is because when the benzaldehyde exposes to air, it can undergo an auto-oxidation and convert itself to carboxylic acid, and that's why it's common to find carboxylic acid, specifically benzoic acid, as an impurity in the benzaldehyde bottle. So this impurity, the mechanism of formation of this impurity is explained in a radical mechanism where benzaldehyde undergo homolytic cleavage into a carbon and the carbonyl hydrogen, whereas the oxygen also cleavages its pi bond and forms two radicals. These biradicals are very reactive, that they're able to insert between the carbon hydrogen bond to form a per acid, specifically perbenzoic acid. So what happens is this perbenzoic acid further proceeds to Baeyer-Willinger oxidation. In some textbooks you may find this Baeyer-Willinger oxidation explained as intermolecular rearrangement, but to make it easy for you, we will see it here in a stepwise. So the perbenzoic acid first undergo hemolysis by departing its hydroxyl proton, and the hydroxyl proton will be absorbed by the one aldehyde in the container, and then again this oxygen anion from the perbenzoic acid, from the per acid, again attacks the carbonyl carbon of the aldehyde which took the hydrogen, and they create this intermediate. And because of the oxygen-oxygen radical is the oxygen-oxygen double bond is unstable, what happens is the hydrogen of one of the aldehyde carbonyl carbon will leave its bonding to the carbon oxygen to make a double bond, and the the oxygen splits and the oxygen bond becomes an ion on the other uh, carboxylate fragment, and that produces the first carboxylic acid. And the second carboxylic acid is formed from carboxylate ion upon abstracting the hydrogen from the solution, and then we end up having two benzoic acid formed from two benzaldehydes after undergoing auto oxidation. So to prevent this, normally we wash the benzaldehyde solution with sodium bicarbonate, because sodium bicarbonate reacts with benzoic acid to form sodium benzoate, which is a salt, and it is soluble in water, and the sodium bicarbonate. So the what we do is, once we dissolve this benzaldehyde, and benzaldehyde, as we see from the previous slides, is insoluble in water, and the sodium benzoate is soluble in water, which means if these solution are mixed, they will make layers, which will help us to remove the aqueous layer very easily and purify the benzoic acid. Experimentally, we're going to do that by preparing 10 to 50 milliliter of 10% sodium carbonate solution, and then we will take 5 milliliter of benzaldehyde first into the separatory funnel, and then we will add 5 ml of our sodium carbonate solution. And to assure an efficient reaction, we have to shake the separatory funnel, but shaking should not be overdone, which it may result in making an emulsion, and that emulsion may prevent us to get a clear layer between these two immiscible liquids. So we can do this 3 or 4 times, as much as possible, by just separating the aqueous layer. Every time you add the sodium bicarbonate solution, you'll have 2 layers. The bottom layer is the aqueous layer containing the benzoate salt, and you can remove very easily by opening the separatory funnel cork or the adjuster at the bottom. And once you wash this several times, you can then wash with 5 ml of water in the end, and again you can separate the water from which will be the bottom layer, and then you can collect benzaldehyde by just the same way you remove the water. So the above layer will be the benzaldehyde. So it's just to draw down the separatory funnel and collect it in a separate flask or beaker. Next procedure will be to purify the benzaldehyde from any humidity which may come from the water, and to do that we will filter and dry it using magnesium sulfate. So magnesium sulfate is a dehydrating agent, so when we add from 0.5 to 1 grams of magnesium sulfate, it will absorb any remaining water droplets. And then to get rid of the magnesium sulfate, you can simply undergo a gravity filtration. To do a gravity filtration, we need to prepare a fluted filter paper, which is prepared by folding the filter paper, Wortmann filter paper usually, into 4 folders or 5 folders, which is okay in either way. So you can just fold it into half, fold it into quarter, and again you can fold every quarter into half. Then you will end up having good fluted filter paper, and then simply you can draw in or pour your solution of benzaldehyde mixed with magnesium sulfate into the filter paper, and you'll find the benzaldehyde at the bottom of the flask, and the magnesium sulfate will certainly be contained in the filter paper. Now, once we purify the benzaldehyde this way, again the problem comes, because as far as we are working under normal environments, we must expect that the benzaldehyde we purify can be recontaminated again anytime when it is exposed to atmospheric oxygen. However, we have a good solution also to prevent that, and that is to add hydroquinone into the benzaldehyde solution. Why? Because when oxygen contaminates the bottle of the benzaldehyde, the hydroquinone will react faster than the benzaldehyde, and the oxygen will be contained within the oxygen will be contained within the bottle, but not in a way that changes the benzaldehyde to carboxylic acid, but by converting the hydroquinone into benzoquinone. So you can see the mechanism how it converts 2 moles of hydroquinones into 2 moles of benzoquinones and 2 moles of water. Well, one of the important issues to remember about safety in every chemistry lab is the waste disposal, and the magnesium sulfate, which we use it to dry our sample, is now a solid waste, whereas the sodium benzoate salts, which we remove them by dissolving in aqueous solution, are all going to be aqueous wastes, and we must do the experiment in the fume hood. I mean, it's expected that we were doing the experiment in the fume hood, and we have to make sure to clean the hood at the end of the experiment. And that's all for this experiment. If you have any questions or comments, please leave them on my YouTube channel. Thank you.